Hello everyone, welcome to this video. In this video, we shall be seeing what are prime subfields. So what are prime subfields, right? So recall that in the previous video, what we did was, we saw what is the characteristic of a field. We saw that the characteristic of any field could either be 0 or it is some prime number p, right? So if the case is that the characteristic is equal to p, where p is some prime number, then all the elements can be written as the sum of ones to form zp inside the field. That is, it form a subfield. What does this means? This means that it forms a subfield which is similar to or isomorphic to this field zp, the field of addition and multiplication modulo p. And in that case we have the characteristic p. What does that mean? It means that whenever you take p uh, once, that means you take the multiplicative identities and you add them p times, then you'll get the additive identity, right? So this was what we done in the previous video. For example, if you have this field Z3, then the only elements are 0 bar, 1 bar and 2 bar. That means when you take any integer, when you divide that by 3, whatever is the remainder comes under these three classes only. So here in this case, the characteristic is 3. So you add up 1 3 times, you'll get 3. When you divide this 3 by 3, you'll get the remainder as 0. So the characteristic is 3 in this case. Moreover, this ZP would be the smallest subfield in the field that it can contain, right? It would be the smallest subfield. So this thing has to be noted, that such field is the smallest subfield. Moreover, if the characteristic of the field is 0, in that case, the elements would contain a copy of natural numbers inside the field. If the characteristic of this field is 0, that means if you take the multiplicative identity and you add it to itself, then you will get different elements. Like you add 1 3 times, then you will get 3, and if you add 1 5 times, you will be getting 5, and so on, right? So with this multiplicative identity, you will get every element of this set, which is the set of natural numbers inside the field. So it would mimic a copy of natural numbers inside this. The set of elements, together with their additive and multiplicative inverses, they create a copy of rational numbers inside the field. So in this case, we must say that the smallest subfield which is contained in the field is the field of rational numbers, right? So let us see what are prime subfields. Let us look at its definition. The smallest subfield of a field is the prime subfield, and it is either the field of addition and multiplication modulo p over the set of integers, or it is the set of rational numbers, right? So what does this prime subfield means? It means that you have some field f. So whatever is the smallest subfield, that would be called as the prime subfield. It is as simple as that. Moreover, this prime subfield is generated by the multiplicative identity if of the field. Whatever is the multiplicative identity, you can generate the whole subfield through this, right? So that means every element of this field can be obtained by adding ones a finite number of times, right? So we have one more definition for this prime subfield. We can understand this using this concept also. If we are having some field f, and we know that the intersection of several subfields is again a subfield. So the intersection of all the subfields is a subfield which is unique and minimal. So whatever is the intersection of different subfields, that is unique, and it is the minimum of all those. That is also true. So this unique minimal subfield of this field f is called the prime subfield of f. So this is as simple as that. So that means if you have any field f, if you take different subfields, say f1, f2 or f3, then you take their intersection. So this intersection would be unique, and moreover it would be a subfield, and the least subfield, the subfield with two elements, would only contain the multiplicative and additive identities, right? So this would be the smallest in certain case containing two elements. So let us look at one example. We have a field F. It has 16 elements, say, right? So its subfields have two elements. It could have two elements, it could have four elements, it could have 16 elements. How do we calculate that its subfields, they contain only two elements, four elements, or 16 elements? That we shall see in the upcoming videos. As for now, what would be the prime subfield of this field F? It would be the smallest subfield. So in this case, the subfield would be the one with two elements in it. That would be called the prime subfield. That is it for this video. I hope you liked the video. Thank you for watching.